Okay, here's 8.6, example 2. So I mentioned that you could use chain or columns. We're going to do another example. This time we're going to find a power series to represent the function x over 1 minus x squared. Now you'll see this a few times. As soon as you see these parentheses squared in the denominator, the entire denominator is squared, you're going to think derivatives. So we can still solve it using a chain if we wanted. I'm going to write down the first few steps of that and then I'm going to stop. And I'll show you the column method. For the first few steps, I would take my x over 1 minus x squared. I would factor out the x on top. So that gives me an x times 1 over 1 minus x squared. And then I would have to recognize that this second term on the right, this term, is the derivative of 1 over 1 minus x. We're going to anti-differentiate. So this is x times the derivative of 1 over 1 minus x. When you take the derivative of this right term, you get two negatives that cancel, so that's why there's a 1 on top instead of a negative 1. So we could keep going if we wanted, and you're certainly welcome to try that. The other method involves two columns. If you notice, in the chain format, we start with the example that we want. This is what we wanted. And in the middle, we use the geometric series. In the column method, you start with what you know. You know that 1 over 1 minus x is the sum of x to the n from n equals 0 to the infinity, and that happens for x's less than 1. We're never going to really use this on the right side again because when you take derivatives, as you saw in the reading, the interval stays the same, so things are nice. So if I want to look like our original problem up at the top, I think I'm going to have to take a derivative. That's how I'm going to get this squared outside. So I'm going to take the derivative of both sides of my equation. When I take the derivative of the left, I get 1 over 1 minus x quantity squared, and that's going to equal the derivative of the right. When I take the derivative of the right, I take the derivative of each term. The derivative of x raised to the n is n times x to the n minus 1. Now you can say from n equals 0 to infinity, or you can notice that when you plug in a 0, the first term is a 0 because of this n. So you could also start at n equals 1. That's personal preference. The book will start at 1 to say the 0 didn't matter. We're going to leave it out. Now we look back at what we wanted up here. The only difference is there's an x on top. So I'm going to take both sides of my equation and I'm going to multiply them by x. On the left, that gives me the equation x over 1 minus x squared. And on the right side, that gives me x times the series from n equals 1 to infinity, n times x to the n minus 1. But just like before, we want to simplify that so it's a series with nothing in front of it. When we do that, the n gets left alone. We're bringing in an x and combining it with the x to the n minus 1, which is x to the n. Again, from n equals 1 to infinity, and if you started at 0, it wouldn't matter. So that's our final form. We now know that this function can be represented as this series. One example where this is useful is in a later class that you could take, probability. Sometimes you get a series of the form, let's say the series n over 3 to the n, and you're asked to add it up from n equals 1 to infinity. Well, starting here and actually writing out the first few terms doesn't get you very far. 1/3 plus 2/9 plus 3 27s plus 4 81sts, and so on. Can't figure much out from there. You could, if you wanted to spend a lot of time, be a little bit clever. Instead, you can say that this series on the left is the same as the series n times 1/3 to the n from n equals 1 to infinity. And now we recognize this is exactly the series we just found up here, except they've plugged in a 1/3 for the x. Since we know that that matches our function, our formula up here, we can plug that in. That's a 1/3 divided by 1 minus 1/3 quantity squared. So that's 1 divided by 3 over 1 minus 1/3 is 2/3. Square that and you get 4/9. So that's 1 over 3 times 9 over 4, which is 3/4. So we've now added up a series that would be pretty hard to add because we recognize that this series can be written as a function. So we go both directions with these. So I hope that helped, and have a great day.